We're going to cover two different methods here for solving. The first one is the factorization method. This is where you first factorize the quadratic trinomial, and from there then you find its roots or you solve it. The second method we'll look at is the minus b formula. Now, there's multiple ways that you might be able to do your factorization, but for the purpose of this, I'll be looking specifically at the guide number method. If you want to go back and revise the guide number method before going through this video, then my advice would be to go back over the factorization video where the guide number method is stepped through in more detail. Okay, so we're going to look at a few different examples. The first one will be solving a quadratic trinomial using the guide number method. So that's really the factorization method. And then the second example, we're going to use the minus b formula. And then we're going to look at the discriminants, using the discriminants to find the nature of the roots. Okay, and that's at the roots of a quadratic trinomial. So I just have a little piece about the discriminant to do, and then I'll do one example. So this video hopefully will be a little bit shorter than the others. So let's go straight into it. So here's our first example. So the question is simply solve 3x squared plus x minus 14 equals 0. So we know it's a quadratic because it contains an x squared, an x and a constant. Just to draw your attention to this x here. So what we don't generally write in maths is the one that appears before this. Now, if you want to put in that one to help you, that's absolutely fine. What I would equate it to is if I said to you, I have a dog, you will be able to tell me I had one dog, even though I didn't use the word one. So similarly, just writing x, there is an x there. So there's one x there. So there should be a 1 in front of it. So that's just something that may help. So like I said earlier, if you want to revise the guide number method in more detail, there is a factorization video. So I'm just going to crack through this. So our guide number in this case is negative 42, and that's coming from 3 by minus 14. And then we need the factors of that. So 7 sixes are 42, and the way that these should look, it should be a plus 7 and a minus 6, which will add to give me a plus 1, which is what we want. So now we're going to rewrite it. So 3x squared minus 6x plus 7x minus 14 equals 0. So now we're going to do grouping. So 3x is common, leaving us with x minus 2, plus 7 is common, x minus 2. Our brackets are now common. We have x minus 2 in both. Just take that out and we're left with 3x plus 7 equals 0. So at this point what we've done, and just for us to follow what we're doing, these are the factors. But this question is asking us to solve it. So when we solve it, what we actually want is an answer. So we want x equals. So how we do that is we let each of our factors equal 0. So x minus 2 equals 0, and 3x plus 7 equals 0. So this gives me x equals 2, and then this is 3x equals minus 7. So x equals minus 7 over 3. If you want to write in a decimal, you can, but leaving it as the fraction here is perfect. So what we've actually done then is we have solved it. They're our answers. But each of these are actually called our roots. Now we go into a bit more detail about factors and roots in the video where we're looking at graphing, and specifically looking at the polynomials and working from the roots back to the polynomials. So again, if you want to check that out for more information, that's absolutely fine. But for now, just keep in mind that the first step was to get our factors, and then we get our roots. So this is the factorization method because we use factorization, and then once we have our factors, we use our factors to find the roots. So if you're using another type of factorization, not guide number, if you have a different type of factorization that can be used, such as highest common factor, then this part here, so letting each factor equal 0, will still work. So let's look at example 2. The question is solve the following equation to 2 decimal places. Now the question here is very important because 2 decimal places, what they're asking us here is hinting at something quite specific. So we could go along and use our guide number, but what we would find is we would not be able to find the factors of the guide number, which would give us +9. Now what my advice on this would be, if you can't find the factors within a minute, then it's time to use this method. But keep an eye on the question. If they tell us something like 2 decimal places, they are basically telling us that we need to use the -b formula. Now the -b formula appears in your log table, so you don't need to know it off by heart. However, I would always write it down in your question anyway. So let's use our -b here. So what they also tell us in the log tables is this is used with ax squared plus bx plus c equals 0. So the first thing I do is I would go to my equation here, and we should label our a, our b, and our c. So I've just highlighted them there just so we can see, but it's still good to write a equals 2, b equals 9, and c equals -16. So be really careful with your signs there. So let's fill into our formula. So x equals -9, so minus b, plus or minus the square root of b squared minus 4 by a by c. And this is all over, and do follow your formula, it's all over 2a. Now, sorry, apologies. So it should be all over 2, and a is 2, so we sub in 2. So let's clean that up. So we have x equals -9 plus or minus the square root of 81. Now 9's are 81, and minus 4 by 2 is 8, so -8 by -16 will give me a +128, and that's going to be all over 4. Okay, so let's clean that up even more. X is equal to -9 plus or minus the square root of 209 all over 4. So let's go with the positive first. So I'm going to go with x equals -9 plus the square root of 209 all over 4. So we get x is equal to 1.364208. Okay, and then we work with the minus, so x equals -9 minus root 209 all over 4, and when we work that out we get that -5.864208. Now the question asks us for 2 decimal places, so each of them need to be rounded. So this is going to be rounded here, and this is going to be rounded here. So when we are rounding, we need to look at the next number. So since the next number is 4, they will stay the same. So my two answers are x equals 1.36 and x equals -5.8. So example 3, so this is another example of the -b formula, and if we look at the question, it says solve the following equation leaving your answer in surd form. And again, this is a major hint for us that we should be using -b. So in the previous example, we saw that when they use decimal places, that's hinting to us to use the -b formula. And again here, in surd form, or showing us something with a square root. So remember, your surd is a square root. So showing us something with a square root would indicate that that's what we're going to use. So let's write down the -b formula. So x is equal to -b plus or minus square root b squared minus 4ac all over 2a, where we're working with ax squared plus bx plus c equals 0. In this example here, a equals 3, b equals 12, and c equals 1. So subbing into our formula, we get x equals -12 plus or minus the square root of 12 squared minus 4 by 3 by 1, and that's all over 2a. by 3. So let's clean that up. It's minus 12 plus or minus square root of 12 squared is 144. 4 by 3 is 12, by 1 is still 12, and that's all over 6. So to clean that up even more, plus or minus square root, and we have 132 all over 6. So let's go with our positive first. So x is equal to minus 12 plus the square root of 132 all over 6. So instead of putting this into our calculator to get the answer in decimal points, you have to remember that they've asked it for us in third form. So if we look at this, we get minus 12, and root 132 actually simplifies to plus, sorry, this should be equals minus. So root 132 actually simplifies to 2 root 33, and that's still over 6. And that can be simplified a little bit more. So x equals minus 12 over 6 plus 2 root 33 over 6. So that simplifies to minus 2 plus root 33 over 3. And now we can work with the negative. So x equals minus 12 minus square root of 132 all over 6. And working in the exact same way, we'll get x equal to minus 2 minus root 33 over 3. So our two answers, our two roots, are here and here, both in third form. So next I want to talk about the discriminant. So the discriminant is basically taken from the minus b formula, and it helps us to figure out the nature of the roots. So what we mean by nature of roots is roots can be one of three things. They can both be real and different. They can both be real but they're the same number, or they may be both imaginary or not real. So at this point you may not have covered imaginary numbers, and that's absolutely fine, but all you need to know is that they're not real. So here's our minus b formula here, and this is used to get the roots of the equation. So it makes sense that part of this is used to get the nature of the roots. So the bit in particular in this formula which changes, or which has the most impact, is this bit here. So the b squared minus 4ac. And let's talk through first why. Well, let's think of the most basic example. If this number here is 0, so b squared minus 4ac is 0, square root of 0 is 0. So when we go to do our plus or minus, we're doing plus or minus 0. So basically our formula will end up as x equals minus b over 2a. So remembering that all quadratics have two roots, we've only got one answer. So it's not that it only has one root. What it actually means is both roots will be the same. So similarly, if this here, b squared minus 4ac, if that's a positive number that's not 0, so positive number, so that's 1 or above, then we'll be able to add 1 and then subtract it. So we will actually end up with two different answers, but both will be real. If b squared minus 4ac is a negative number, and if you want and have your calculator beside you now, you can try the square root of any negative number, you'll get an error because it is not real. The square root of a minus number is not real. Now, again, you may have covered imaginary numbers, that's fine, but all you need to know at this point is they're not real. So there's three different ways we can look at this. So b squared minus 4ac greater than 0. So what does greater than 0 mean? Well, that means when it's positive. Okay, and we just talked about that. So when this bit is positive, we end up with two distinct, and what distinct means is different, two distinct real roots. So, or if you want to say different, that's absolutely fine. So there's two distinct real roots. So there are two different roots. You might get 3 and 4, but they're two different numbers. When b squared minus 4ac equals 0, remember this bit here in the minus b formula disappears. So what happens here is both roots are the same. Okay, so both roots are the same, but they are real. So they will be real roots, but they'll both be the same. So it looks like we've only one root, but we know that a quadratic has to have two roots. So the third thing then is b squared minus 4ac is less than 0, and by less than 0 we mean negative. So if it is negative then basically the roots are not real. And what you'll find is you'll get an error on your calculator if you try to do the square root of a minus number. So we're going to use this now for the next question. Okay, so let's look at example 4. They're asking us to calculate the discriminant and comment on the nature of the roots for this equation. So the first thing we need is our discriminant, which is b squared minus 4ac, and we're getting our numbers from here where a is equal to 1, b is equal to 6, and c is equal to 5. This is exactly the same as it works for the minus b formula. So let's sub it in. So we have 6 squared minus 4 by a, which is 1, and c, which is 5. So 6 squared is 36, minus 4 by 1 is minus 4, and minus 4 by 5 is minus 20. So this cleans up as being 16, which is greater than 0. And that means we need to comment on the nature of roots. And since the 16 is greater than 0, we know that the roots, therefore, there will be two distinct or different real roots. So if that number had been negative, we would have been able to make a different comment on it. If that number had been 0, we would have been able to make a different comment on it. But when we worked out the discriminant is 16, and because that was greater than 0, we're able to say that there are two distinct real roots. Okay, so let's look at example 5, which is finding an unknown coefficient using the nature of the roots. So find the value of a element of or, which means a is a real number, for which x squared plus ax plus 16 equals 0 has real roots. So they've told us something about the discriminant of the roots. So let's figure out our discriminant then. The formula for our discriminant is b squared minus 4ac. Because they've told us that it has real roots, it must be greater than 0. So using our equation here, we have a is equal to 1, b is equal to a, and c is equal to 16. So let's sub into our formula. So this is a squared minus 4 by 1 by 16. So that must be greater than 0. So a squared minus 64 is greater than 0. So a squared must be greater than 64. Okay, so if we square root both sides, so a must be greater than, so let's square root both sides. Square root of 64 then is 8. But we also need to remember here that when we do the square root of 64, we're asking what number multiplied by itself gives us 64, and plus 8 is really not the only answer. So the square root of 64 could also be minus 8. However, when we take that, we'll be taking it with the opposite sign. So a will be less than minus 8. those are the values where a is an element of the real numbers for which x squared plus ax plus 16 equals 0. So final example here, so example 6, so again looking at an unknown coefficient, but this is working with it slightly differently. So we want to prove that this equation here, kx squared plus 2k minus 1x minus 2 equals 0, has real roots for all values of k. So again, we're working with our discriminant. So our discriminant, is b squared minus 4ac. So here's my a, so a equals k. Here's my b, so b equals 2k minus 1. And then here's my c, so c equals minus 2. So we want to show that it is real roots. So remember to show the real roots, we want to show that it is greater than 0. So let's sub into our formula. So 2k minus 1 squared minus 4 by k by minus 2. So to square this, we're going to have 2k minus 1 by 2k minus 1. And minus 4 by minus 2 is plus 8, and that's by k. So 2k minus 1, minus 1, 2k minus 1 plus 8k. So 4k squared minus 2k plus 1 plus 8k. 4k squared, so we have a minus 2k, and a plus 8k, which is going to end up giving us plus 4k and plus 1. So we wanted to show that it was positive. Looking at it here, well, you might say, well, it depends on what the value of k is. Now, you should be able to recognize that this quadratic trinomial here, if we factorize it, will give you 2k plus 1 and 2k plus 1 again. So actually, that is the product of two factors that are the same. So really what we have is 2k plus 1 squared. Now, any number squared has to be positive. So no matter what k is, when it's doubled and we add 1 and then we square it, it will have to be greater than 0. And you can just write a note here, since any number squared is positive. Okay. So therefore, equation has real roots. So actually, it has two identical real roots, because it's not just greater than 0, it's actually greater than or equal to 0.